Hey guys, continuing on with our chapter 2 work, you should have in the last video filled in the facts about correlation. So we are here at ways to graph two variable categorical data. We talked about scatter plots in the last video. Those were for quantitative data. Really quickly, put the date up here and read through this. We are going to actually do work with this in class. So I want you to kind of have a basic understanding. You can read through these here. What I really do want to talk about today is going back to quantitative data. We're going to talk specifically about regression lines. Okay? So a regression line describes how the response variable, which is y, changes as the explanatory variable x changes. So x is our independent variable, y is our dependent variable. As the explanatory variable, the independent variable changes, how does the response change in turn? Okay, so we're going to use this regression line to predict values of y for a given x. Okay, so maybe we're talking about temperature. We want to predict what the temperature will be on a certain day. We're going to use data from the past to help us get there. Okay. There's three parts of this formula that you see here. Y hat equals a plus bx. Okay. This guy's name is y hat. Just like we had X bar, the Y is wearing like a little hat, so he is called Y hat. Yes, that's a real thing. It's not something that I made up. Okay. And Y hat is the predicted value of the response for a given X. That's why he has a hat. It's not necessarily a true value of y, but it is what we predict y to be. So we call him y hat. A is the y-intercept. Okay, just like it would be if you had mx plus b, these would be flipped around. You'll notice that b is still on there, but now b is the slope, not the y-intercept. In this case, a is the y-intercept. This is just how the College Board writes it, so this is the format that I want you guys to get in the habit of. B would be the slope. Let's think about what the y-intercept and the slope mean in context, taking us back to Algebra 1 today. The y-intercept is the predicted value. I'm going to remind you that the y hat is not an actual value, it's a prediction. So our y-intercept would be the predicted value when x equals 0. It's going to be really important that we include the word predicted in everything that we do with regression lines. Okay? The slope is the amount y is expected or predicted to change when x increases by 1 unit. So instead of saying the amount y actually changes, since this is a prediction line, we're going to say the amount that y is predicted to change. All right, so let's do an example down here, example 3. Common knowledge that cars and trucks lose more value when they're driven. We want to predict the price of a used Ford Super Crew 4x4 if we know how many miles it has on the odometer. Okay, so here's my data. I've listed it for you there. I've already calculated out the correlation, and I've already calculated out the regression line for you. You'll notice that price has a hat on it. That means that it is the predicted price, not the actual price. Okay. Here's the graph of the data. I also graphed my regression line. It's essentially a line of best fit. And we're going to use this to predict the price from miles driven. Okay, so let's identify the slope and the y-intercept in context of the problem. The first thing I want you to do is pause the video and identify from this equation where are the slope and where are the y-intercepts. All right, I have my slope and my y-intercept on here. Let's see if you can interpret those in context. You do not have to have the exact same wording as me, but this is the wording that I have for these two questions. For slope, I said the price is predicted to drop by $0.1629 for every 1 mile driven. For the y-intercept, I said the predicted price of a car with 0 miles driven. That would be the predicted price of a new car, would also be acceptable. Okay. All right, we want to use the regression line to predict the selling price if it has 100,000 miles on it. So we're just going to plug it into our formula. We have price hat, the predicted price, is going to equal $38,257 minus 0.1629 times the miles driven. Plug this in your calculator and we'll see what you get. I have for this one, it would be approximately $21,967. Okay, let's do this again for number 3. We're going to say our predicted price, price hat. Plug it on our formula. Should get something really weird. We have negative $10,000 is our predicted selling price with 300,000 miles on it. Okay. Now the next question, question 4 on the next page, asks us, why did we get such a weird value for number 3? So let's talk about this for a second. Why would we get a negative $10,000? If you look over here at our graph, 300,000 miles is way over here. Okay, somewhere, not even in my chart. If you think about what happens with a used car, I would argue that it's not a straight line. It probably decreases pretty quick at first and then starts to level off as the car gets older. It is probably not a straight line. But what we are looking at on the graph is just this part right here. So yeah, it could be a line. If we're just looking at this first part of the graph, yeah, a straight line might be a good way to model it. However, if we're trying to predict for a value that's far outside our domain, that's going to start to be an issue. Okay. So the issue with here is, why do we get such a weird value? It was outside the domain. Taking you back to maybe Algebra 2 or Algebra 1, domain is your x values. $300,000 is way too high for the x values that you have in your data. Okay, if we look back at what our data is, there is nowhere near 300,000 miles on any of these data points. It's not anywhere near there. So what we have done is a problem. It's called extrapolation, which I have here written in the box. Extrapolation is when a regression line is used for a prediction outside the interval of values of x that are used to obtain the line. When you use the prediction for something outside of your data points that you had for x, it is usually not accurate. So we do not want to make predictions much larger or much smaller than our data. Okay, I have that in the star right there. Okay, so if I think back to what's happening over here, in question 2, I asked for a car with 100,000 miles. 100,000 miles is nice right here on my graph. It falls within my domain, so I should feel okay about that prediction. However, my 300 that I had out here is far outside of my domain, so my graph just kept continuing on, and eventually it went negative. Okay, that one was bad. The first one was okay. So we did not extrapolate for question 2. We did extrapolate on question 3. Do not extrapolate. Very bad thing.